All right, let's look at the homework 12.5, problem number 10. All right, so we want to find the distance between two skew lines. All right, so let's do that. All right, so we have two lines. So first one might look like this, and the second one might look like that. All right, and the first one, so let's find the point. And I'm gonna call it P1 or something like that. Say here is P1. And you just have to find these numbers 1, 2, in this case 0. So P1 is 1, 2, 0. Alright, so P2, is going to be, do the same thing, 3, 4, -2. So 3, 4, -2. Alright. Then we need to find the direction vector. So direction vector here, maybe call it V1. All right, so that's going to be 1, 6, 2. So 1, 6, 2. All right, and the other one, so here's the direction vector here, and let's call it V2. And that's going to be 2, 14, 5. All right. Then if you want the distance, so distance, if you have connecting the 2 points that are closest, so you can see that maybe something like that, and making sure that it has to be perpendicular to both lines at the same time. All right. And first, I'm going to find the vector P1, P2. Right. So vector P1, P2. Right. So this is going to be, all right, so P1, P2. So 3 minus 1 is 2. And 4 minus 2 is 2. And -2 minus 0 is -2. Right? If you want, since everyone's a multiple 2, you can pull 2 out. Right? So you have a 1, 1, -1. Right? Right. So the distance here, since it's perpendicular to both V1 and V2, the easiest way to find that direction would be a cross product. You can take the cross product between V1 and the V2. V1 cross V2 is equal to, all right, so we're going to have to do the determinant, I and J, K, and V1 is 1, 6, 2, and V2 is 2, 14, 5. All right, so this is equal to, all right, so first component is going to be 6 times 5, 30, minus 2 times 14, so it's a 28. All right, so you have a second component is negative. 1 times 5 is 5, minus 2 times 2, so it's 4. All right, and the third component would be 14 minus 12. All right, so this comes out to be, it's fairly nice. It's a 2, -1, and 2. All right, so in order to find the distance, all you have to do is to find the component of P1, P2 in the direction of this cross product. Right, to do that, we can just do this, use the dot product. So we do a dot product between vector P1, P2 with the cross product, but we want to make sure that it is a unit product, a unit vector. So we're going to just divide through by its own length. So magnitude of V1 and V2 goes on the bottom. right? And also we have to make sure that it's positive, so I take the absolute value of that, right? So let's compute this. So this is going to come out to be, all right, so there's a 2 here in front of P1, P2 vector, so I'm going to put 2 in front. All right, then we're going to do a dot product, so it's going to be 1 times 2 is 2, plus, and 1 times -1 is -1, so minus 1. All right, so -1 times 2 is -2. All right, then we're going to divide this by length of the this cross product, so square root of 2 squared is 4, -1 squared is 1, and 2 squared is 4. All right, so what you get is going to be, let's see, so this is going to be 1, so I forgot the absolute value. I have to take the absolute value here. All right, so this is 2 minus 2 cancel out -1 with the absolute value positive 1 times 2, so you have a 2 on top. And you have a square root of 9, which is 3. All right, so we can see that the distance is 2/3. All right, so let's type it in. So we found that to be 2/3. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.